Now that we've talked about similar triangles, we're going to look at some of the postulates that we can use when we're looking at two similar triangles. So if you remember from a couple units ago, we talked about congruence theorems, where we had side, angle, side, 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 nope, sorry, reset, angle, side, angle. We had angle, angle, side. And HL. So we talked about those theorems last time with congruence. And when we talked about those, our other one was side, side, side. We had where all of those were congruent. So all those pieces had to be congruent. Now we're going to talk about the angle-angle postulate, which we didn't have in congruence. But if we have an angle-angle postulate here, that means that if two angles of one triangle are congruent and two angles of another triangle are congruent, then the triangles are similar. So all we have to find for this one is that two angles are similar or congruent in our two triangles. So in part A, we are given that these two angles right here are equal to each other. That is given to us because of these marks right here. They each have one mark in the corner. That tells me they're the same. I also have this cross in the middle. If I have a cross like that, I automatically know that I have vertical angles. Remember, vertical angles are two angles that are straight across from each other in a cross like that. And when we have vertical angles, those two angles are equal. So I'm going to mark two lines in the corners there, so I know that this angle right here is different than this one, but it is the same as this one. So these two are the same, and these two are the same. Okay, so right there I have two sets of matching angles. So this one is yes, they are similar. So we can write our similarity statement. We have triangle ABC is similar to triangle DEC. Okay, B. See, we have a triangle with 70 degrees, so they both have 70. That's one matching one. But here we have 53 and 57. So before I know anything, I need to find the third angle in my triangle. So I know there's 180 degrees total inside my triangle. If I take away 70 and take away 53, so I'll take away 70 first. I'm left with 110, and then take away 53. I am left with 57. So that means this corner right here is 57. So now I can see that I do have another pair of matching angles. So that means these two triangles are similar. They are similar, yes. Triangle, we'll label the points A, B, C, D, E, F. ABC is similar to triangle ECB matches F, EFD by AA. Okay, let's move down to the next one. Here it shows us that we have an isosceles triangle because our two sides are the same, which means our two angles are the same here. So there are two angles that are the same inside of this one triangle. But for us to have angle, angle, we need to have an angle from this triangle matching an angle in this triangle. If we look at this, our triangle ABC only has one line in that corner. Triangle DEF has two lines in that corner. So that means those angles are different. So that means this one is not similar. Okay, in our next example, it's asking us to complete the similarity statements. So if triangle SRT is congruent to our other triangle, so let's label, we have SRT is this little triangle. Our second triangle is going to be the big triangle here. So that would be triangle WRT. X. By angle. So we have this angle here that matches, and then we also have the vertex at the top. That angle is in both of our triangles. So here, this is wanting us to write a proportion. So if we have RS, this side right here, RS, would be proportional to RW on the bottom. That proportion, those two sides of our triangles, would also be equal to the proportion of another set of sides. So if we do the other side, RT, that would go on top because we're putting our small triangle values on top. And then our large segment would be RX. Then we can do the same thing for our third side. We would have ST in our small triangle, and then WX in our large triangle. Okay, we got one more here. It says solve for X. So if these two similar triangles are 6 and X on this side and 2 and 4 on this side, we need to set up a proportion so we can solve for X. So we need to match up our sides. We have 4 and X here, so we can write those two numbers as a ratio. 4 to X is going to be the same as 2 to 6. So see how I started with 4 on my first one. I started with a number from my small triangle. So I need to start with the number from my small triangle on top over here, and then 4 to 6. Now I can cross multiply. X times 2 and 6 times 4. Get 2x equals 24. Divide by 2. Get x equals 12.